Okay, so here are your notes 5.1, started the new section of the new chapter or unit. Um, this is going to be, we're going to use properties of exponents to simplify or evaluate expressions. So we're going to start with expressions like most of these units. We're not solving yet. We are going to get into different operations and things we're going to do with polynomial expressions. But in order to get to that, we have to figure out how to work with exponents. All right, so in class we discussed this. The exponent properties are just shortcuts. I'm just going to do a couple of these since we already did these in class. So if you actually take this literally, x squared times x to the third, x squared means x times x. X to the third means there's x times x times x. So if you count them up, 1, 2, 3, 4, 5, there's 5 x's, so that's x to the fifth. So basically what these properties are, somebody in the past said, well, I'm tired of expanding it out because that was the only way they knew how to do it. They thought they saw a pattern, and the pattern was, hey, every single time that we multiply these, if they have the same bases, I just take one exponent and add it to the other one. 3 plus a 2 is a 5, and I get this. And that ended up being one of the properties. There's a lot more. For example, this property right here is the same one. So what you would do, instead of putting x 6 times and x 2 times and counting them up, you just do 6 plus 2 and get x to the 8th. Same thing here, same kind of theory. So there's another one. This was with multiplying, this one's with dividing. If you actually expand that out, x to the 8th means that you have x 2, 3, 4, 5, 6, 7, 8. And there's some weird piece there. Take that away. All right. Okay, so there's 8 x's and then 3 more on the bottom, 2, 3. Since these are all being multiplied, you have one equivalence here, one equivalence here, one equivalent there. So what you're left with is 5 x's on the top, and then nothing on the bottom, so it's just a 1. So what they found out was, hey, when we divide, then this happens. This will happen every single time. So that's the same thing of thinking about 8 x's on top, 3 on the bottom, and then they'll cancel. You can just say, okay, well, 8 minus 3 will get me this number also. Okay, so we did in class. Here's the properties. We have a product of powers, which is this. Quotient of powers, which is this. We just went over those two in the previous screen. Power of a power, which is this. Power of a product. Power of a power means that you take them and multiply them when you have a power raised to another power. Power of a product, you have a product and then you're taking a power of it. Power of a quotient, you have a quotient. It's almost like you're distributing. You can kind of think of it like that. We covered all these in class. So these are basically just ones that come up from the expansion model. So remember, the expansion model is this. You can prove any one of these using this expansion model. So what we're going to do right now is we're going to use these to help us do different things. And hopefully you guys remembered how we explained this, the negative exponent property, we explained that in class, and the zero exponent property, we explained that in class too, because that wasn't very intuitive why a to the 0 was a 1, but we explained all that out. Common mistakes, we went over these also, so please don't make these mistakes. I'm going to go ahead and go over these though. There is no power of sums property. There's nothing with a plus in the minus in the middle. That should be a multiplication. So common mistake I see, which is not right, is they turn this into a squared plus b squared. That is not a squared plus b squared. Okay, you cannot just distribute the 2 in when you have a plus sign in the middle. It's not the same thing. If you think about this as a plus b times another a plus b, there would be a middle part here if you actually multiplied it out. Okay. Another thing here, people see 0, they want to put a 1 right away. So biggest mistake I see students make here is they say, okay, there's a 0 power there. Anything to the 0 power is a 1. Problem with that is that the y is the part that's to the 0 power. So this part is the part that becomes a 1. 5x squared stays the same because this is the only, like I said, this is the only part that becomes a 1. So the actual correct answer should be a 5x squared only. All right, so for this one with negative exponents, we discussed this in class. Negative exponents basically bring it, if it's a numerator, it becomes a denominator. If it's a denominator, it becomes a numerator. So right now this is over a 1. What I see people do here is they put a 1 over 2x to the 4th. That is not correct. The correct answer should be 2 on top, because if you look at this, the 2 has a first power here. That first power is a positive power, so it stays where it's at. It's the negative powers are the ones that move. So this x to the 4th is the only thing that should have been brought to the bottom. The 2 would have stayed on top. So the correct answer would have been 2 over x to the fourth. All right, and the one that I see most common mistake on this one is people put 5x to the sixth, y to the eighth. That is not correct. Reason being, once again, this 5 does have a 1 on it, 5 to the first power. So if you use the power of products property, excuse me, it's almost like you're distributing it in. So it'd be 2 times the 1, 2 times the 3, and 2 times the 4. So if you look at this, they did the 2 times the 3 and 2 times the 4, but there should also be a 2 next to this 5 right here. 5 squared, x6, y8. Okay. It's just a clarification thing. So let's go over this first example. So for example, you do have to tell me the properties that you're using. So this property has parentheses. Now if you notice, anything with parentheses, if we go back to here, the reason is power of, power of, power of. Anything that has a power of is usually going to have something in the parentheses, and then there's a power on the outside. And then the second word is telling you what's on the inside. So power of a power means you have a power of a power, meaning there's a power on the inside. Power of a product means you have a power, and then you have a product on the inside. Power of a quotient means you have a power and a quotient on the inside. Okay. So let's go back to this one. Okay, 2 to the third to the fourth power. So this one, you would take the 4 and multiply it to the 3. So that'd be 2 to the 12th power. And then we used power of power. Power of power. Pow pow. I'm fine with you guys saying pow pow. 2 to the 12th power. Big number. Can't do that one in my head. Okay, 2. Where's my power button? Your power button might look like this, or it might have like a little caret symbol. So 2 to the caret symbol like that on your calculator. 12th power is 4096. So equals 4096. And then the reason behind that is just simplifying. Right. And like I said, I am okay with you guys abbreviating your reasoning behind each part. Now this next one, you can actually do this one of two ways. You can use the negative exponent property, where you can put this 1 over negative 5 to the 6th. Or if you look at this, it's actually multiplication of the same base, so you can do the product of powers property, which says you take this negative 6 and you add it to the 4. So you do negative 5, negative 6 plus 4 is a negative 2. That's the product of powers. So you do have to get really familiar with those different properties. You're not done yet though, because simplest form, most of the time, what they mean is you should not have a negative in your exponent. So we got to get rid of that negative. We're going to use the negative exponent property, which means that this will now come into the denominator. 5 squared, negative 5 squared. So that's the negative exponent property. And one last thing is we can actually evaluate this, because we do know what negative 5 squared actually becomes, which is a 25. That's called simplifying. All right. These should be somewhat familiar to you. You've done these in Algebra 1, that's why I'm kind of going through them without much explanation, but they should be kind of familiar. So we're going to get more in depth here. So simplifying an algebraic expression, state the property used for each step. So this one, you can actually approach this one of two ways. First off, you can focus on the quotient part, and when you have a quotient, you can subtract, or you can focus on the power on the outside and distribute it in. Those are two ways you can approach this to begin with. I would say, personally, I would want to do the quotient of powers property first, because if I subtract 7 from a 5, I'll get a smaller number than if I multiplied 3 times 7 and then 3 times 5 and then subtracted after that. So it's just a matter of preference. So either way is a valid way of starting this. So what I'm going to do is I'm going to take the 7 and this 5, since I do have the same base of an x, and I'm going to subtract them. So 7 minus 5 is a 2. So I'm going to get an x squared, and then you still got that 3 on the outside. That was quotient of powers property that I just used. Okay, so now the next step is, now I have a power of a power. So I'm going to go ahead and multiply it in. So it's going to be x to the 6th power, and then that's it. So that was the pow pow. power. Can't evaluate that because it's a variable, so you got to stop there. Next one, I'm not sure why I put parentheses around that. I think there's supposed to be a number here. So just add, let's add in a number. So let's put a 5 here because I think there was a typo there. So just assume that there was a 5 there. So if we got a 5 here, we got probably the best way to approach this one is actually go ahead and multiply the 5 in. Now, as a general rule, just to help you not make mistakes, you should probably put ones wherever you have actual ones as exponents. So for example, this x has a power of 1 right there. All right, so what we're going to do here is this. Looks like the first step, we want to kind of tackle these parentheses first, I would say. You can't really do the quotient because this is inside of a group. If you're going to be mixing this bottom part with the top part, you got to get this group off of here. So let's go ahead and multiply the 5 in. So it's going to be x to the 5th, y to the 10th on the top over x cubed y to the negative 1. So only do one property at a time. So the property we just did was the power of products. Okay. You'll know it would be a power of something when you have a parentheses going on. That should start with the word pow. Pow. Okay. Like right here is power of a power because you had a parentheses. Let's see here. So the next thing we should do looks like we can use the quotient properties here. Quotient of powers, 5 and 3, 10 and negative 1. So basically what we're going to do is we're going to take the 5 minus the 3. 5 minus 3 is a 2, so we got an x squared. Then we're going to do 10 minus a negative 1. 10 minus negative 1 is 10 plus 1 plus y to the 11th. And that was the quotient of powers. And that's it. Since x and y's are different bases, I cannot put those together. All right. Let's try another little bit more complex here. So like before, we should probably put some ones on here just to make sure that we hit everything. So this is 5 to the first power, x to the second, y to the 7th, 4 to the first power. Now there's nothing on the outside of this one, so I could put a 1 out here also, just so I can distribute it to get rid of these parentheses. So the first thing I would want to do is get rid of the parentheses. Now I can do 2 at a time here because these are both the same property I'm using. So I'm going to distribute the 3 here and the 1 here, okay? And we're going to be using the, what is that, pow of. Since I'm dealing with parentheses, I can start with pow of, so here, those are products. Power of products. So that's going to be 5 to the 3rd, x to the 6th, y to the 21. This is multiplied, so we are multiplying. Everything's being multiplied. 1 times 1 is 4 to the 1st times y to the 8th. Okay, I'm going to go ahead and bring these numbers to the front. So 5 to the 3rd and 4 to the 1st. Oh, there's the bell. So let me pause this. All right, the bell rang. So 5 to the 3rd times 4 to the 1st, we just brought those to the front. Now what I'm going to do is go ahead and we'll figure out what else we can put together here. So x to the 6th, there's no other x's, so they have to be the same base in order for most of these properties to work out. These didn't need to be the same base because I'm not really putting them together. All I was doing was multiplying the 3 into each part. Now when I put them together, they can't really go together unless they have the same base. So there's only x to the 6th, so x to the 6th stays the same. Hold on, I left my pin by my desk. Okay, so x to the 6th. So that was this one. Now what's left is y21 and y8. They're being multiplied. There's no parentheses, so it's not a power of anything that we're going to be using to put those together. So far all we did was kind of rearranged, but that was it. We didn't put together anything yet. So now we're going to put the y's together. Now they're being multiplied, so it's a product. So I'll start with product of powers. I didn't abbreviate that. So 21 and the 8. So the question becomes now, what do I do with 21 and the 8? Since there's no parentheses, I'm not multiplying, so I must be adding. So it should be y to the 21. ninth. Now, if you think about this, that makes sense because this is 21y's. If you were to expand it, there'd be 21 of these. Expand that, there'd be 8 of them, and you just count them all up, and you should come up with a 29. Not quite done yet because 5 to the third times 4 to the first can be multiplied. 5 to the third, 5 times 5 is 25, and another 5 is 125. 125 times 4, so 125 times 2 is 250. There's 4 of them, so that's going to be 250, so 500, I'm hoping. 500 x 6 y 29. Okay, so think about that one more time. So 5 to the third is 125. 125 times 2 is 250, and then there's another 250. Add those, you get 500. Yeah, that should be right. If not, then I did something wrong, and you can tell me tomorrow and get extra credit. Now remember, for each step, we do need a reason. So the reason behind from here to here is power of products, product of power. So this last step, all I did was multiply. So I'm okay with you guys either put simplify for that. Oh, you don't gotta box it. Okay. All right, example 4. So let's do this one out. For this one, there's a couple of places that you could start. My suggestion would be work with the parentheses first, but if you look at this closely, you could actually do the 4 and the 6 down here first. Subtract those if you wanted to. But like I said, I'm going to go ahead and use the power of products here and get this 3 multiplied in here so I can take these parentheses off. So this will become 4. So if I multiply that in, you can get x to the 15th, y to the 6th, and then x to the 4th. The bottom I didn't do anything with, so that's 2 to the 3rd, x to the 6th, y to the 8th. All right, now at this point, you can do one of two properties. Oh, gotta put the property that we used here. So this was the power of, because there was parentheses involved. Remember, that's going to start with the power of, and then there was products here. Power of products. Power of prod. Okay. So the next part, you can either put the 15 and the 4 together. You can take the 6 away from the 15 or the 8 away from the 6. There's a couple different options you can do here. And it's really up to you which way you want to go, because you should end up with the same answer if using these, because it's going to make it, basically the whole thing is here, this expression will become smaller and smaller as you put stuff together. So as long as things are going together, you're doing something correct. Okay, so I'm going to go ahead and work on the top, do this 15 and this 4, put these x's together. So there's no parentheses, so I know I'm not multiplying them, so I must be adding them since they're all across the top. I'm not mixing it up with the bottom yet. So 15 plus 4 is a 19. Y to the 6th. There's nothing to go together on the bottom, so that's just going to stay x6, y8. Okay, so the property we used here was, it was just the 15 and the 4 we put together, so that's the product of powers. Okay, next part, I'm going to want to put this 19 and the 6 together, and this 6 and this 8, because you'd be using the exact same property. That property is with a division, so that's the quotient of powers. That's where you subtract. So the 4 and the 2/3, what I'm going to do is, since this is just a number, it's not really dealing with the variables at all, I'm going to pull that off to the front. So 4 and 2 to the 3rd. And then I'll just do everything else over here. So, oh, I actually don't need that division bar, because since I am subtracting, it's just going to become, it's not going to be a fraction anymore. So 19 minus a 6 is x to the 13th. 6 minus 8 is y to the -2nd. It's the quotient of powers that we use there. One more step, because I shouldn't have a negative on here. Or actually a couple more steps. So I got to get this negative. Right now it's on the top. It's going to go on the bottom. There was 2 to the 3rd is on the bottom already. So it's going to go down there with that one. So 4x to the 13th stays on the top, the numerator. This is a negative, so it's coming down to the bottom. Whoops. It's not an x. That is a y. Y to the positive second. That was a negative exponent property. We know that because we were dealing with a negative exponent. And we're almost done. One part here is that we got a 4 over 2 to the third. You can turn that to 4. 2 to the third is an 8. 4 over 8 does simplify down to 1 over 8. So, 4 over 8 simplifies down to 1/2. So there'd be a 2 on the bottom. Another way you can think about this is 4 is a 2 squared. 2 squared, 2 to the third, 2 minus 3 is a negative 1. Negative exponent, bring it down. It's kind of a lot with the working with properties. These are smaller numbers, so you can go ahead and just work with this. So 2 to the third is an 8. So 4 over 8, that's going to be 1/2. So x to the 13th over 2y squared. Reason behind that, that's just all simplifying. Okay. Now, this last one was going to be a think, pair, share that you were going to do with your neighbor. I want you trying this on your own. I want you, and then tomorrow we'll kind of discuss it at the beginning of class. But basically what I want you to do is simplify this, but I want you to do it in 3 different ways. So actually, this kind of makes it a little easier, more precise. I want the first step to be different in the 3 different ways that you're doing this. So after the first step, you can start using the same steps after that, but the very first step, I don't want it to be the same thing. So if you use the product of powers on one of them, I want you to use the quotient of powers on another one, okay? So should be 3 different ways. So first step, 3 different ways for this one. And that is it, okay? Have a happy Halloween and bye-bye.